Hi, this is Nimla Rednam. In this video, we are going to discuss kite. Now, what is a kite? It is a quadrilateral. A kite is a quadrilateral. Okay. And here you have distinct consecutive pairs of sides of equal length. What do we mean by this? Now, if you look at the examples here, it will be more clear to us. If you look at the first figure, ABCD here, you will see that AB is equal to AD. The symbol denotes sides of equal length and BC is equal to CD. Now, these two equal length sides are consecutive, right? And I have one more consecutive pair BC and CD, and this is distinct from the first pair. Therefore, it is a kite. Okay. Similarly, in this second figure you see here, you will see that this is one pair of one consecutive pair of sides of equal length, and this is the second consecutive pair of sides of equal length. Therefore, it is a kite. Now, in the third figure, you will see that this is the first pair and this is the second pair. Therefore, it is a kite. Okay, so these are examples of kites. Now, if you look at these figures over here, you will see that in the first figure, it's not a quadrilateral in the first place because you have 5 sides. Therefore, it's not a kite. Now, here I definitely have sides of equal length, but they're not consecutive pairs, they're opposite pairs, right? So, this is not a kite. Now, similarly, in the third figure, you will see that if you consider this as your consecutive pair of sides of equal length, then the second pair is not distinct from it. It's not distinct in the sense you have a common side for both these pairs. Therefore, it does not satisfy the condition and it's not a kite, right? So, this is about kite. Here, I would like to point out that the use of the word exactly is not necessary. In fact, it is misleading and incorrect in the sense, if you look at the square itself that they have mentioned in the next line, you will see that you can form two distinct consecutive pairs of sides of equal lengths in two different combinations for a square. Okay, so check whether a square is a kite. A square is a kite. Why? Let us check that. Let me draw the figure. So here I'm going to draw a square, right? So if I draw a square, okay, now this is a square, right? Okay, so now for this, we already know that these sides are of equal length. All four sides of a square are of equal length, right? Now, what do we need in a kite? It is a quadrilateral, yes, and I need two distinct consecutive pairs of sides of equal length, right? So, if I name the side lengths as 1, 2, 3 and 4, okay, you will see that if I take 1, 2 as one pair and 3, 4 as the other pair. These are consecutive pairs and they're of equal length. Therefore, it is a kite. Okay. Now here, the reason why I'm saying you can't say exactly two distinct pairs is I can take a different combination. For example, I can take 2, 3 and 4, 1. Okay. So that's about it. Just to make sure that you don't all of a sudden get confused why they're saying exactly 2. Okay. Let us not use the word exactly for the definition of a kite, right? Now, if you want a more accurate alternative definition for a kite, let us look at Wikipedia once. Okay, so here I have let us see kite geometry. What is the definition? Now here you will see that the definition, there are four alternate definitions that they have given, right? So here, if you look at this definition and classification section over here, so here, if you look at this definition, right, look at the third definition that they have given here. They're talking about one diagonal is a line of symmetry, right? One diagonal is a line of symmetry, okay? It divides a quadrilateral into two congruent triangles that are mirror images of each other, okay? Now, this is the key word here, okay? One diagonal is the line of symmetry. That's it. That's all we need to remember in order to understand what a kite is. One diagonal is a line of symmetry. One diagonal is a line of symmetry for a kite. Here, let me magnify the four definitions that they have given. Okay, can you see? Yeah. So, out of these four definitions, I'm saying that this particular one here that says one diagonal is a line of symmetry is very useful and very easy to understand the kite more intuitively. Okay. So that's about the definition of a kite. Now let's look at the activity that they have given, right? So here they're saying that they want you to take a white sheet of paper, fold the paper once and draw two line segments of different lengths as shown and cut along it and open up. Let's do this. So here I have a sheet of paper. I'm going to fold it once, right? And draw two line segments in this manner randomly. You don't need any particular angle and you don't need these sides to be equal. Okay, so let me draw something like this. Now I have to cut along this, right? So what I get out of this is a kite. Let's just check that. Okay. So you will see that what we have here is a kite. Okay. Now this is nothing but a kite. So the first question that they're asking us is, has the kite any line of symmetry? Okay. Now clearly you can see that in this particular quadrilateral, this is a line of symmetry because when I overlap along this, everything is exactly overlapped without any problem. So this is nothing but a line of symmetry. Okay. So yes, the kite has a line of symmetry. The next question they're asking is, fold both the diagonals of the kite. Use the set square to check if they cut at right angles. Okay, let us answer this question first. One diagonal is already folded, right? In order to fold the second diagonal, you have to go along the corner. Make sure you do this to the corner, and then so this is my second diagonal, right? This is my second diagonal. Let me just draw on the crease so that it is clear. So this is my original diagonal which we used in order to get this kite. Okay, and this is the second diagonal. Simply by folding, you need not draw it. I'm just drawing just for the sake of clarity. So these are my two diagonals. Now they want us to check if they cut at right angles. That is, the angle here is 90 degrees. Okay. Use a set square for that. You will see that you can immediately check that yes, it is 90 degrees. Can you see? This is clearly 90 degrees. Okay. So the answer for that is yes. Are the diagonals of equal length? Now clearly in this case you can see that they are not of equal length. Okay, so this longer diagonal is around 11 centimeters, whereas okay, this one is a little less than that. It's about 10.5 to 10.7 centimeters. Okay, so you will see that the diagonals need not be of equal length. You might get accidentally you might get diagonals that are of equal length, but by the definition of a kite, they need not be of equal length. The diagonals need not be of equal length for a kite. Now, verify by paper folding or measurement if the diagonals bisect each other. Okay, what do you mean by paper folding? Now, let's not do the measurement. We are going to use paper folding. So, this is the point of intersection of the diagonals, right? Now, this right here is the point of intersection of the diagonals. So, if I fold it along one diagonal, okay, passing through the point of intersection, clearly this is the upper, for the second diagonal, this is one part and this one is other. The second part is longer, right? So clearly it is not bisected. Okay, one diagonal in this particular model that I got is not bisected. What about the second one? Let us see. Now I am going to fold it along the second diagonal and you will see that these two corners exactly coincide with each other. In fact, this is how we formed this kite. So clearly this diagonal is bisected. So one diagonal is definitely bisected. The second may be bisected, may not be bisected. When it is bisected, it's a special case, right? So that is about verify if the diagonals bisect each other. You can say that one diagonal is always bisected. You can't say about the second diagonal. By folding an angle of the kite on its opposite, check for angles of equal measure. So they want us to check for angles of equal measure. So clearly these two angles are equal. You can see that they coincide exactly. They are overlapping exactly. Okay, so one is not greater or less than the other. They are exactly equal to each other. So this pair of opposite angles are equal. What about the other pair? So if I join the opposite vertices here, you will see that this is smaller. Okay, can you see this angle is smaller compared to this angle? This is a little larger. So that means that they are not of equal measure, the opposite angles. Okay, so I have one pair of opposite angles of equal measure. Observe the diagonal folds. Do they indicate any diagonal being an angular bisector? Okay, so if you look at the four angles here, is any diagonal bisecting the two opposite sides of the kite? So if you look at it, if I fold along this, I'm calling this the first diagonal, you will see that this angle is the same as this angle, right? So that is, this angle is equal to this angle. Similarly, because this side is, exactly coinciding with this side, I can conclude that this angle is same as this angle, right? So this first diagonal does bisect these two opposite angles. Now what about the second diagonal? If I fold along the second diagonal, you will see that here I have this angle is smaller compared to this angle. Clearly there is it's not overlapping exactly, right? So clearly this angle and this angle are not equal. Similarly, this angle is not equal to this angle. Okay, so what can you say? Which diagonal is the angular bisector? The line of symmetry. The diagonal, which is the line of symmetry, is the angular bisector for the kite. Now, we are going to list them all. Okay, let us list them. So, let's quickly recap and then we are going to list them. Okay. First point is you have a line of symmetry for a kite. This is my line of symmetry. Okay. Now, the diagonals bisect each other at right angles. Okay. That is the second point. And next you have one diagonal is bisected. Okay. One diagonal in a kite is bisected. And the next point is you will see that the line of symmetry diagonal also is the angular bisector. Angular bisector, right? So that is one more point. And then one pair of opposite angles are of equal measure. Okay, so this pair is of equal measure, right? So these are the points. Let us list them down. So I have a kite. Let us put the heading kite. And we are going to list down the properties of kite. Okay. So the first point that we noticed is it has a line of symmetry, right? So a kite has a line of symmetry. In fact, this is the definition that I suggested we go with, right? A quadrilateral with a line of symmetry is nothing but a kite. Next, the diagonals are perpendicular to each other. In a kite, the diagonals are perpendicular to each other, right? Next, the diagonals need not be of equal length. One diagonal is bisected. One diagonal is bisected. Next point, one pair of opposite angles are of equal measure. Okay, so one pair of opposite angles are of equal measure, right? Next, one diagonal is an angular bisector for two opposite angles, which is actually covered in line of symmetry, but let us just mention it. One diagonal is an angular bisector. Angle bisector. Okay. For the corresponding, the vertices that contain this diagonal, right? For the corresponding vertex angles. Okay. So that is another point. And so that is it. So these are the 5 points that we have noticed in the kite through the activity that they have given. So let me quickly draw the figure once. Okay, so I have a kite here. If this is one line segment, okay, so this is another line segment of something like this, okay, and something like this. Right, now this is my kite. If I have to draw the diagonal, this is one diagonal. Sorry, 1 second. Yes, this is one diagonal. This is my second diagonal, right? Good. Now here, let us check all these points that we have written. Okay, let me name the kite A, B, C, D. Okay, now clearly you can see that AB is equal to AD, BC is equal to CD. Okay, AC is my line of symmetry, right? And the diagonals are perpendicular to each other, and one diagonal is bisected, which is the diagonal here. This is the diagonal that is bisected. BO is equal to OD. So the diagonal that is bisected is BD. Okay, one pair of opposite angles are of equal measure. Okay, which is that pair? Angle B is equal to angle D. So that pair is B comma D. One diagonal is an angular bisector for the corresponding vertex angles. So which diagonal are we talking about? We are talking about AC here, okay? And the corresponding vertex angles are angle A and angle C. That is, AC bisects angle A, okay? So this angle is equal to this angle, and it also bisects angle C. So this angle is equal to this angle, right? So these are the 5 points. So with this, we come to an end of discussing kite. In the next video, we are going to start parallelogram. Okay.